Hi, my name is Andy Waterhouse. I'm a professor in viticulture and enology, and also right now I'm director of the Robert Mondavi Institute. Wine oxidation is probably the oldest problem in wine preservation. In fact, Louis Pasteur is famously quoted as saying, "Oxygen makes the wine." And he did some experiments showing how oxygen changed wine. It was quite dramatic. Today we know there's a little bit more to the story, but still it's really true. The longevity of wine is really based on its oxidation. How did I get started on this? Well, many years ago, not sure exactly how many, I was teaching my wine chemistry class to graduate students. At the end of the quarter, one of the students came up to me and said, "You know, Professor Waterhouse, I really liked the class, but I was expecting to learn more about wine oxidation." And I said, "Alice, you're right. I really should dig into that a little bit more." And I started looking into it and got so interested in it that a couple of years later, when I took sabbatical leave, I went to New Zealand to work with Paul Kilmartin. So Paul is at the time, pretty young chemist, but he had studied wine oxidation at a pretty significant level, and he was doing research using a technique called cyclic voltammetry. So I was there for several months working with Paul, learning about cyclic voltammetry and how he could measure wine oxidation using that technique. And during that time, I got a phone call from Davis, and they told me, "I've been awarded this new thing called the Chancellor's Fellowship." It was a big surprise, of course, and it was even bigger surprise because I'd never heard of it. I was in the inaugural year of that program. So it was a great honor to get this in the very first year they were offering it. And when I came back to Davis, I had a new graduate student named Felipe Lori from Chile. And we were trying to figure out what he should work on and decided, well, it has to be something related to oxidation. And we decided to look at this process called micro-ox, or micro-oxygenation. Now, micro-ox is a process that had been around for about 10 years, and winemakers in France and in California were using it fairly routinely, but they were having a lot of trouble controlling it. So we did some experiments trying to figure out how it worked. It was invented in this area of France called Madiran by a fellow named Patrick Ducournau. And in Madiran, they make wine from the Tannat grape, which is very tannic. And really, to make the wine saleable in less than a decade or so, he invented this process to actually add oxygen to accelerate the aging process and make the wine, say, older in a quicker process. So we wanted to study how that worked. Now, you may have heard of this if you've seen the movie Mondovino, because there's a famous wine consultant that goes around the world. His name is Michel Rolland, telling everybody that to improve their wine, their red wine, they have to use micro-ox. So if you see that movie, that's what he's talking about. Now, after Felipe finished up his studies, Ryan Elias came to do a postdoc at Davis, and he started looking at the oxidation chemistry in detail. And to study a reaction in detail, chemists use a technique called kinetics, where you study how fast something happens. And on this slide you see the only figure I'm going to show you, which is the loss of oxygen during a test reaction that Ryan did, looking at how quickly the oxygen disappears. And by studying the slope of the line and how long it takes, you can delve into the mechanism of the reaction. You begin to understand how things work, and you can start to predict then how things should happen, assuming that your theory is correct. So what I'm going to do now is I'm going to shift gears and I'm going to show you a couple of examples of where we predicted things to happen a certain way and it didn't happen the way we expected. And that's where you really make discoveries, right? Where you discover where something you thought should happen didn't happen. And so we'll look at two examples of that. So when Ryan finished, Michael Webb started his postdoctoral position in my lab, and he set up a special micro-ox container to study this process in very small scale with tight control. And we actually stole some ideas from Paul's lab in New Zealand about how to set this up. And we started looking at how this micro-ox was proceeding. And unlike that nice smooth line where we saw oxygen disappearing, what we saw was it was completely unpredictable. Things were going faster, they were going slower. And so we were completely confused by this. But Mike was a very good observer and noticed that not only was the chemistry odd, but physically the solution was bubbly and it was cloudy. And that started to clue us into what was really going on, which is sort of disappointing for a chemist, but it wasn't chemistry. It was microbiology that was controlling the process. So when Mike finished up, Charlie Henshin started. He's a master's student and now a winemaker at Tuomi. And he took the system that Mike set up, and we said, okay, we're going to do a controlled experiment and completely remove any yeast. So we got our wine from a winery that needed to be treated with micro-ox. We filtered half of it and put that in some tanks and didn't filter the other half. And what we saw was in the filtered wine, basically nothing happened. The oxygen slowly disappeared, but we didn't see any oxidation products. Whereas in the unfiltered wine, after a couple of weeks, we saw the yeast suddenly appear. We didn't see them initially. And when they appeared, the oxygen levels crashed and acetaldehyde levels shot up. So it was pretty clear that it was the yeast doing the work here. And they're making acetaldehyde, which is what winemakers want when they run this process. Because the acetaldehyde has the effect of masking this vegetal aroma that apparently nobody likes, and also improving color in the wine. So winemakers do this process routinely now in order to get rid of that vegety aroma they don't like and provide more color to the red wine. So the result of this, well, we've now done this experiment many times, and we've confirmed the fact that pretty much if you do micro-ox, if you want to produce acetaldehyde, you need yeast, and you also need a little bit of sugar there, and that will lead to an effect that's desired, and it's controlled. So this gives winemakers a tool where they can control an important process in winemaking. Now the second example I'm going to talk about has to do with aging wine in a bottle. And I figured some of you probably even have bottles of wine at home that you're aging, but more than a week. We're talking about aging for maybe a decade or so. Now, the container that you have your wine in is a glass bottle and has a cork in the top. And this technology's been here for about 250 years. Okay, that's when bottles got strong enough and somebody thought of putting a piece of cork into the neck, and that produces a good seal, and so the wine can last for decades. Before that, really, when people talked about old wine, what they meant was stuff that was more than a year old, okay? Because there was really no way to keep it from oxidizing very quickly. So with the bottle and a cork in it, you get in with not the 250-year-old technology, but today's, you get about 1 milligram of oxygen coming into the bottle every year. And it doesn't sound like a lot, but after several decades, it adds up, okay? So there are problems with the corks. You may have heard of corked wine. There's alternatives now. Some winemakers use screw caps. You can get plastic corks, synthetic corks. You can get corks that are manufactured from natural cork by removing all the taint and then putting them back together. So there's alternatives, but the natural cork is still very popular. Now, student Anita Peterson was studying the formation of acetaldehyde and its reactions, and I told her, well, one of the things you need to do is go down to the cellar and get your hands on a couple bottles of new and old wine, and let's measure the amount of acetaldehyde and see what's going on. So when she did that, she recovered some older bottles, about 15 and 20 years old, and we went to measure the acetaldehyde, and it turns out it was much less than in the new bottles. And this was completely confusing because we expected as the wine ages and there's oxygen coming in every year, the wine's getting more and more oxidized, the amount of acetaldehyde should be increasing, not decreasing. So this was rather confusing, but it suggested that maybe the cork is slowing down the amount of oxygen coming in. So a few years later, I had a Chinese visitor, Guomin Han, who came to Davis, and he was working on the technique for analyzing acetaldehyde. And after he finished developing, improving the technique, I told him, okay, Guomin, let's go down to the cellar and get some old bottles and get some new bottles and see what's going on. And he got the same result as Anita. In other words, he saw that in the old wine, if you look on this table here, you'll see that in the 50-year-old bottles, the amount of acetaldehyde was much less than in the sort of recently bottled wine. So this was confirming this observation that, okay, in really old bottles, there's less acetaldehyde. So this was again suggesting that perhaps what was happening is as the corks age in the bottle, somehow they're reducing the amount of oxygen coming in. So we decided we had to do an experiment to test this, and we got in touch with the collaborator at Delaware, and Annegret Cantu in my lab is the scientist here at Davis who's doing this experiment. And we collaborated with a winery in Napa called Cade, and Cade gave us bottles of wine that was sealed with the same cork, or from the same company anyway. It was bottles that were a year old and bottles that were 10 years old. And what Annegret did was we collaborated with a company down in Modesto called G3, and they cut the neck of the bottle right off with the cork in the neck. And you could take that glass tube now and hook it up to a machine and measure how much oxygen is going through the cork. And what we observed is that in the new bottles, or the new corks that is, the amount of oxygen going through was about what we expected, about 1 milligram per year. But in the 10-year-old bottles, the amount was about 1/10 as much, 0.1 milligrams per year. So in fact, even in this specific example, and we'd had multiple bottles, the amount of oxygen going through the cork actually decreases as the cork ages with the wine present. Now, how is this happening? We theorize that what's happening is that the wine is going into the cork, and when that happens, it turns out that will greatly slow down the rate of oxygen transmission through the cork. In other words, when the oxygen molecules bump into liquid inside the cork, it really slows them down. So that can explain now how the decrease is happening. And if you've ever opened a really old bottle of wine, one of the things you often encounter is that the cork falls apart when you try to get it out of the bottle. And the reason that's happening is the wine has gotten into the cork and has actually broken down the cellulose and lignin a little bit, so it loses its structural integrity, right? So it's not strong like it was when it went in there. And eventually, of course, if you don't do anything, or wait many decades, then the cork will actually get completely loose in the bottle because it loses its capacity to press against the sides of the bottle. And if you look in a very old wine cellar, you'll see wine seeping out of bottles, leaking out because the corks have started to fail completely. And of course, in those cases, then the wine gets oxidized very quickly. But until that point, the wine is actually protected from oxygen coming in by this breakdown of the cork. So if you have old bottles of wine at home, I suggest when you open them up, if you can get the cork out intact, what I've done lately is take the cork and get a very sharp knife and very carefully cut the cork in half and see where that liquid is in the cork. And that we believe, we now have a big experiment going on where we're going to be following a bunch of bottles for a couple decades, looking at how much the cork changes in terms of the amount of oxygen coming in a very controlled experiment. So I hope you've learned a little bit today about wine oxidation, and Maybe you'll have some party tricks you can do with cutting a cork open. Tell your friends this is what really preserves wine and allows us to taste wine or enjoy wine when it's 20 or 30 years old, because the amount of oxygen coming in the bottle is much less than it used to be. So to wrap up, I'd like to thank a number of sponsors of our research. Of course, UC Davis for the Chancellor's Fellowship many years ago that got us started down this path, but also the American Vineyard Foundation for their support for our work over the years in wine oxidation, and a number of wine companies and closure companies that have been very supportive as well. And thank you for your attention.